This time, let's talk about simple and compound propositions in Lesson 2. Let's define first the difference between simple proposition and compound proposition. So if we are going to say simple, we're just talking of a declarative statement that cannot be broken down any further into other component propositions. Sentences having only one thought, and also called atomic propositions because they are the building blocks of propositional logic. So when you say that you are just pointing out on one proposition or single thought, meaning that is simple proposition. When can we say that a proposition is compound? We can say if it is formed by combining two or more simple categorical propositions by some logical connectors. So if the two propositions having single thoughts are combined using logical connectives such as not, and, or, if then, and, if and only if, so it is considered as compound proposition. Okay, let's try to determine whether each of the following statements is a compound or simple proposition. Statement 1. Rhombuses are squares. Is it simple proposition or compound proposition? Yes, it's very clear that it is simple proposition because we are talking of rhombuses only and they are squares. Second statement. It is not the case that square root of 5 is a rational number. It is not the case that square root of 5 is a rational number. Is it simple or compound? Yes, it's compound proposition. Why? Because if you are using the statement or the phrase, it is not, meaning you are pointing of one logical connector which is negation. So, this statement is clearly a compound proposition. The word not is a logical connector. How about the third statement? 7 is a prime number. Is it simple or compound proposition? Yes, it is a simple proposition because we're talking of 7 only, which is a prime number. How about the fourth statement? If the sky is cloudy, then it will rain. If the sky is cloudy, then it will rain. So we are using here the connectives if, then. Meaning, since we are using a connective, this is not a simple proposition, but it's already a compound proposition. So, statement 4 is a compound proposition. How about the last statement? A triangle is equilateral if and only if it's an equiangular. A triangle is an equilateral if and only if it is equiangular. So is it simple or compound proposition? So here we are using if and only if, which is a logical connector. Therefore, this statement is clearly a compound proposition. Yes. Now, let's consider the symbols of the connectives and examples here connecting P and Q in symbols. The first one is the symbol, yes, symbol and, or it can also be described as but or yet. But all the three connectives are just like the symbol given. So it just refers, one of them refers to the symbol given. Say for example, if we will connect statement P and Q here, we'll just say P and Q, where N is written in symbol. Second, or. How are we going to write or in symbol? Or can be written as this. And if you will connect statements P and Q, this is just P or Q. So, as what you could observe, the two connectives and or are different from each other. Or, if you can see the symbol, the first one is like, yes, and the second one is like letter V, and the other one is like, yes, V, but it's placed in the opposite direction. Okay. The third one is implies. Implies or if then are just the same. So these connectives can be symbolized as arrow pointing to the right. So if you are going to combine or connect statements P and Q, that is P implies Q, where implies or if then is written in symbol. The fourth one is equivalent to, or it's commonly used as if and only if connector. This is symbolized by, yes, arrow pointing to the right and left or both directions. So if you're going to connect P and Q, that is P if and only if, Q written in symbol. The last is the negation. If you will say not, it means you are using the connector not or the connective not. So it is symbolized as this, like approximately, or yes, it can be used as, say for example, not P, so you will use this symbol. Let's have an example here. So given the statements P, CJ is a math teacher, and Q, CJ is a lead passer, write each symbolism in ordinary English sentence. So how will you do that? Let's try to write the English sentence in this. One is P and Q. So we will just replace P and Q by the statements. So we have CJ is a math teacher and she is a lead passer. How about the second? As what you can remember, this symbol means implies or if then. So it's commonly used as if then collective. So we will replace P by the statement CJ. If CJ is a math teacher, then she is a lead passer. In statement 3, you will just get the, yes, inverse. We will just change the placement of Q and P here. So if CJ is a lead passer, then she is a math teacher. We are still basing it from the statements given. Fourth one, not Q or not P. Not Q, CJ is not a lead passer, or CJ is not a math teacher. So that is simply the English sentence in statement 4. How about in 5? Not P, if, not P, if and only if Q. So we'll start with P. Not P is CJ is a math teacher if and only if she is a lead passer. So that is the English statement in statement 5. English sentence, I mean. Okay, so if we are given this one, let's try to write each compound sentence in symbolic form. Let's have the first one. If the sky is cloudy, then probably it will rain. So write each compound sentence in symbolic form. Let's start with, since the statement says that if then, the if then is used as connective, so we will use this symbol here in implies or if then symbol. So let P be the statement the sky is cloudy, and Q is the statement it will rain. Next, a triangle is right if and only if it has 90-degree angle. We all know that if and only if is symbolized as this one having two arrows to the left and to the right. So if you are going to consider the first statement as your statement P, a triangle is right, and the second statement as statement Q, proposition Q, a triangle has a 90-degree angle, so its symbolic form is P if and only if Q. Let's move on to the third statement. 2 is prime and even. Simply, it uses the connective and. So, we learned a while ago that and is symbolized as like, yes, the opposite of V. Let P be the sentence 2 is prime, and P be the sentence, Q be the sentence 2 is even. So, P and Q. Fourth statement, study hard or you will fail. So, it's very clear that we will let the first statement be statement P, and the second statement you will fail be the statement Q. So, we have here P or Q. In the last statement, prices are going up but wages are not. Let P be the sentence prices are going up, and Q be the sentence wages are not going up. So, what connective are we using? But. So, but is, yes, similar to and. So, we will use the symbol, yes, not Q, since wages are not. Okay? So, I hope you understand. That ends our lesson.